Section 2.7, solving equations in one variable. Let's make it happen. So the book says for this example to solve it by clearing fractions. Basically, they told you from the jump how you want to approach this question. Nobody likes to work with fractions, so the strategy here is get rid of the fraction. And we get rid of fractions the same way every single time. You guys remember how to do that?
Multiply by the denominator.
My man, multiply by the denominator. So what we're going to do is we are going to distribute the denominator, which is x, to the entire equation. I have to write slow because the recording program really messes with my computer. Here we go. So distribute that x everywhere. If you do it properly, you will have no more fractions. Instead, what you're going to get is x squared plus 3 equals 4x. And this is a quadratic. All quadratics are solved the same way. Get everything to one side and go from there. So I'm going to have to subtract that 4x to the left side. Gets me x squared minus 4x plus 3. And now we just factor. Or use a quadratic formula if it's a bad question, but it's not. We can factor this one. You're looking for the two numbers that multiply to positive 3 that add to negative 4. Negative 1, negative 3. Negative 3, negative 1. Order doesn't matter.
Negative 1, negative 1, positive 4.
No, they both have to be negative in order for it to multiply to be a positive 3.
Well, then wouldn't it be negative 4, negative 1?
No, because these two, so negative 4 and negative 1 would multiply to positive 4, but they would add to negative 5. We need them to multiply to positive 3 and add to negative 4. What it gives us is x equals 1 and x equals 3. Now, what you have to do for any kind of question that has variables on the bottom, which is why we graphed these things first, is you have to make sure that you don't have x's that are not allowed. So when we were starting this chapter, we were graphing a lot of these things, and we had to focus on finding asymptotes often. And vertical asymptotes happen whenever the bottom of a fraction equals 0. So even though algebra gave us two answers, that doesn't guarantee they both work. You always make sure answers are allowed as your very last step. So as long as your answers don't break the rules of any fractions, then they're fine. And the only fraction I see is 3 over x. That means the only answer that would not have been allowed would have been x equals 0, because you can't divide by 0. And since neither one of those answers is x equals 0, they both work. We don't need to check them. And you're welcome to check them, but you don't need to. They work. Ta-da! That's not bad, is it? Bless you. Mm-hmm. We're good? No questions, comments, concerns? Everybody's all right, cool. All right. Problem may look different, but guess what? Same basic strategy. Got a fraction? We don't want to deal with a fraction? Cancel a fraction. It's done exactly the same way it was done last time. You're going to multiply everything by the denominator. This time the denominator is a little bit trickier. It is x minus 4 rather than just an x. Right here, you should automatically see the answer that is not allowed to be. X cannot be 4 at the very end. So if we get x equals 4, we cross it out. It's not allowed. It's good to just identify that at the very beginning. We're going to distribute x minus 4. Well, at least one of the distributions results in a 0. Well, that one's easy because it's a 1. I'm going to show the work before I distribute. Because distributing that x minus 4 is going to cause me to distribute again. I will have to distribute this x right here.
When you do it over the fraction, the
Yeah.
x minus 4 over x minus 4, wouldn't that simplify to a 1?
Yes, it does.
But you have x minus
You're right.
4 written down.
That's one of those mistakes I was talking about. Yeah. Yeah, that would have just been a 1. How about that? See? It just doesn't matter how much caffeine you have. Good thing someone in the room has brains. But room? I don't know. She's technically not even in the room. How come everybody's going to let me do that wrong? What's wrong with you people? How many times I told you,
Well, no,
don't let me do it wrong?
1 minus x minus 1 times x minus 4 is x minus 4.
Right, but it's divided by x minus 4 still. So it would be x minus 4 over x minus 4, which simplifies to 1.
It's like having 3/3.
No, it would have been x minus 4 over x minus 4, which does simplify to 1. All right, now we're going to distribute that x, get x squared minus 4x plus 1 equals 0. And again, quadratic. So we hope it factors. Oh, no, this one doesn't factor. Shucks. So how are we going to solve it? Quadratic formula. I'm not going to sing this time. I'm just going to write the quadratic formula because I don't want to. Would you stop throwing things in my room?
I was trying to throw it away.
I know. You were trying to throw it away, but you missed. So we're going to plug things into the quadratic formula. What's it give me? X equals, well, b is already negative, so I have negative negative 4, which is positive 4, plus or minus square root of b squared is 16 minus 4 times a, which is 1, and c, which is 1. All over 2a, well, that's just 2 times 1. So it's going to give me 4 plus or minus the square root of 12. 16 minus 4, 12. And 12 is not a perfect square. However, I can reduce it because it does have a perfect square that goes into it as a factor. And the factor of 12 that is a perfect square is what? 4. It's 4. So what we're going to do is we're going to call that root 12. We're actually going to call it root 4 times 3. And what we can do is we can take the square root of parts and bring them out. So the square root of the 4 can come out as a 2. Now the 3 will be stuck inside that radical. Sorry, 3, you're stuck. And the very last step, because both the 4 and the 2 can be divided by 2, we have to divide them both by 2. So this gives me 2 plus or minus the square root of 3. And since neither one of those answers is x equals 4, we're good. They both work. 2 plus root 3, 2 minus root 3. So barring the mistake I made at the very beginning, are there any questions on a question like that? It's basically the same, just a slightly more difficult denominator and less pretty answers. But the process is the same. Clear the fractions, solve the resulting quadratics. So we'll make sure everybody's cool with that one before we get to the harder ones, quote unquote, harder ones. So what makes the harder ones harder? Well, more than one fraction, more than one denominator, factoring. Ah, we have a question. Yes, sir. You sure? Okay, well, never mind then. So what I was saying, more than one fraction, more than one denominator, and factoring. These are the things that could make these questions more difficult. And oh, look, this one has all three of those things. More than one fraction, more than one denominator, and factoring. So where do we begin? You begin by factoring. Anything that can factor should be factored. That should always be the very first step that you take. If you can factor, do factor. Nothing to do with this first fraction. Nothing to do with the second fraction. But, and I believe we've already seen this in these notes, x squared minus 4x plus 3, this does factor. We'd be looking for the two numbers that multiply to give us positive 3 that add to be negative 4. And like I said, we've already seen that. And guess what? They're these two things. It's x minus 3 and x minus 1. Order doesn't matter. Now, in the previous two examples, the process was to distribute the bottom of the fraction, right? Well, there's more than one bottom of the fraction here, so what do? What we do is we identify the least common denominator and we distribute by the least common denominator. If you do that, all of your fractions will disappear. For example, and you don't need to write this unless you want to, if I had an x over 2 plus a 1 over 3 equals, I'm just going to x squared over 4, you know? Just making something up with easier things. 2, 3, and 4. What is the least common denominator? 12. See, if we distribute a 12 across the entire thing, and I am going to erase this for space purposes, but if we distribute a 12 across the entire thing, and I'm showing the work, you'd get 12x over 2, which will simplify to 6x, plus 12 over 3, which will simplify to 4, equals, not plus. Waiting for the board to catch up with me. Come on, panel. You can do it. Maybe you can't. There we go. Equals 12x squared over 4, which would be 3x squared. So you see, if you do it properly and you distribute by the least common denominator, every single fraction will clear. So that's the process. Like I said, I'm going to have to clear that for space purposes. But you're looking at our polynomials, our rational functions, I should say. All three of these are rational functions. And you're asking yourself, what would the least common denominator be? Yes, sir.
Why are you multiplying everything on top by 12 instead of multiplying like the denominators, like the whole thing, like x over 2,
Well,
6,
technically, 12 is 12 over 1. Oh, that's the eraser. Every whole number can be thought of as being over 1.
Yeah, but like,
So what you're doing is you're multiplying everything by the fraction 12 over 1. So you have x over 2 times 12 over 1. Got it? Okay.
like why would you, like for the x squared over 4, why would you just multiply the top by 3?
Because you multiply everything by 3, you have 3x over 2 plus...
Like you multiply like the denominator of that fraction to get to 12, so like x over 2.
Oh, well, if you did that, so what you would be doing right there is you'd be trying to make them all have the same denominator, right? Now, if you did that, you know that the least common denominator is 12. So if you made all the denominators 12, then you'd have to combine your fractions. And you'd have something over 12 equals something over 12, right? And because the denominator is already matched as a 12, you would just stop talking about them. And you would just set the tops equal to each other, right? If you do what I just did, it jumps automatically to the tops equal to each other. It skips over the process of making the denominators match so you can combine the fractions. We're skipping over that process. We're just trying to clear the fractions instantly. Is that okay?
Couldn't
Yes?
you clear the fractions by multiplying each part by a part that would make all the denominators equal? Like for 2x over x minus 1,
Yeah.
if you multiply that times x minus 3, then the denominator will become equal to everyone else. And you can cancel the denominators out if you also multiply 1 over x minus 3 by x minus 1.
Well, again, that would be doing the same thing. That would be trying to make all the fractions have the same denominator just so you can combine the fractions.
Yeah.
I'm trying to avoid combining the fractions. Because if you can skip over the step of combining the fractions, then you're less likely to make a mistake with distributing a negative sign or something like that. That's why I'm doing it this way. I'm just trying to avoid having fractions at all. We're just trying to clear them from the jump. So McKinley, you kind of already figured it out. You realized that in order for my denominators to all be the same, I need them to become x minus 1 times x minus 3. That is the least common denominator here. So what I would say is, why bother changing each individual fraction when you could just distribute x minus 1 times x minus 3? If you distribute this quadratic to all three places, all three fractions disappear. Now we don't have to worry about fractions at all. Not trying to combine them or anything.
Well, no, wouldn't the x minus 3...
But wouldn't that not work?
Hold on. Two questions at once. Max?
Wouldn't the x minus 3 show 1 over the x minus 3 is left, so an x minus 1 is bottom?
How about, I tell you what,
Wait, no,
I'll show the work and then I'll cancel out.
I know why.
And McKinley, you were trying to ask a question?
Yeah, wouldn't that not work? Because, oh wait, I realized how you're doing it. You're canceling out the bottoms using the tops. Okay.
Right. So I'm going to go ahead and show all the
I'm
work.
very used to canceling the bottoms out, which is why I was confused.
Right. Canceling the bottoms is a more efficient way of solving these things. Again, did we have to do it this way? No. You're welcome to make them all have the same denominator and then attempt to combine your fractions and then solve from there, but I'm telling you it's more work and you're more likely to make mistakes. So I prefer to just clear all fractions from the very beginning. Do you have to do it my way? Absolutely not. You are more than welcome to do whichever method you're most comfortable with. I'm just trying to save you time. Like this. Like I said, if you do this right, every single fraction will cancel. There are no fractions now. So the first one just is 2x times x minus 3. The next one is just x minus 1. I'm not even going to bother with the parentheses. Oh yay, somebody's printing to my printer for the third time this morning already. And on the far right side, I just have a 2. So yeah, there's another distribution going on. You got to distribute this 2x right here. Uh-oh, running out of vertical space. Get skinny, math. So this gives me 2x squared minus 6x plus x. And we know we're going to have a quadratic, right? So I'm going to have to move everything to one side. Are we comfortable with me subtracting 2 right now as well and getting this minus 3? So 2x squared minus 5x minus 3 equals 0. And what we hope, because it is the easiest way of solving a quadratic, is that this thing will factor. And, panel just tried to crash on me. Let's try that again. Come on, catch up with me. There we go. And guess what? It does factor. Factors using our Lizzie method. If you don't remember how it works, it's okay. I'm going to review. We are looking for the two numbers that will multiply to a times c. Our a times c is 2 times negative 3, which is negative 6. And we need those two numbers that multiply to negative 6 to add to b, which is negative 5. I forgot to write b. So I'm looking for the two numbers that will multiply to negative 6 and add to negative 5. And negative 6 and positive 1 is the way to do it. Watch out for the trap negative 2, negative 3. It doesn't multiply to negative 6. But negative 6, positive 1 will work perfectly. So the way the Lizzie method works is you take your quadratic and you split it into two sets of parentheses right now that both begin with an x. X equals, so not x equals, x, and then plus or minus, x plus or minus. Great. Now we take our two numbers we just found, that negative 6 and that positive 1, negative 6, positive 1. And what makes this the Lizzie method is right here, dividing by a. That's what makes it the Lizzie method. The Lizzie method is great for solving quadratics because it gets to solutions one step faster than factoring does. The AC method does, excuse me. You just reduce your fractions if you can. 6 over 2 reduces to 3, so we have x minus 3 and x plus 1/2 equals 0. And this allows me to see my two solutions right now. It's whatever numbers make the parentheses equals 0. So my two solutions would be x equals 3 and x equals negative 1/2. And like I said, anytime you're working with a question where there were x's in the denominator, the very last step is to make sure your answers are allowed. Your answers can never make the denominator equal 0 at the very beginning. Uh-oh. Yeah, one of my denominators was x minus 3. So that means at the very beginning of the question, we knew x was not allowed to equal 3. So the algebra gave us an answer that is not allowed. This is called an extraneous solution.
I have a question.
You have a question. What can I do for you?
Shouldn't our answers be 2x plus 1 times x minus 3?
So 2x plus 1 times x minus 3 is what you get if you finish factoring. So the last step of the Lizzie method for factoring is to take anything that still has a denominator and scoot the denominator in front of the x. But the solutions are what makes the inside of the parentheses equal 0. So if you move that 2 to the front of the x and you go 2x plus 1 equals 0, you will get x equals negative 1/2. So if the question just said to factor the polynomial, you're right. I didn't finish, quote unquote, factoring it. But as far as solving is concerned, I can solve one step faster using the Lizzie method. And that's why I do it. It's good for solving.
Okay.
So yeah, x was not allowed to be 3 at the very, very beginning of the question. It's called an extraneous solution. An extraneous solution is a solution that algebra gave you that was not allowed to happen. You guys good with that? Anytime there's an x on the bottom, your last job, whenever you're solving one of these things, make sure the answers were allowed. So is it possible that I had 2 correct answers? Absolutely. Is it possible there's only 1 correct answer? You just saw it happen. Is it possible to get no correct answers? Oh yeah, definitely. The math
Algebra was
could
like,
lie.
here, have this. Oh,
Yeah,
but you
the
can't
math could
use
lie
it.
to you. And you know why the math lied to us? Because the very first thing we did was eliminate the denominators. Now you remember what we did the last couple of days when we were graphing? Anytime you eliminated a denominator, you created a removable discontinuity. So what happened was we created possible removable discontinuities by canceling those denominators. We just had to make sure that our solutions wasn't one of the removable discontinuities. That's what we were doing there. Okay. Clear those. Eventually. There we go. Same idea, eliminating extraneous solutions. Again, very first step, always the same. Anything that can factor should be factored. And I'm looking at the last denominator of x squared plus 2x. It factors. There's a GCF in that last denominator of x, leaving behind an x plus 2. Now, again, I could go through the process of making them all have the same denominator and then combining the fractions, but I think that that is harder to do than to just say what is the least common denominator, and I will just distribute that least common denominator so I don't have any more fractions. Well, one of the denominators is x, the other is x plus 2, and the last one is x times x plus 2. Guess what? X times x plus 2, that is the common denominator. It already has the other 2 denominator parts. It has an x, it has an x plus 2. So we just distribute x times x plus 2. The whole thing. And it does have to distribute to all 4 places. Come on, there we go. To the 0, which is still going to be 0. Like that. And I will show that work. I'll show me canceling the fractions. Do you have to show you canceling the fractions at home? No. If you can see it happening in your head, cool. Here's the x plus 2, and the x minus 3. All that's over x. That's the first distribution. The next distribution gives us 3x, x plus 2 over x plus 2. And the last one, 6x times x plus 2 over x times x plus 2. Whoops. Did I say plus? Or did I just skip over it? And I wrote equals. Okay, I can fix it. Check this magic out. Now it's a plus sign. Ta-da! Thanks. All right, well, here we go. That fraction's gone. That fraction's gone. And that fraction's gone. Yay, no fractions. We do have to watch out for extraneous solutions, though, because we just eliminated denominators. Go home, too. You're drunk. Let's try that again. When the board lags, everything gets jagged when I write. Now, unfortunately, at the very beginning, at the very beginning of the process here, I am going to have to FOIL x plus 2 and x minus 3. I'm going to go out on a limb and say that everybody in the room knows how to FOIL. I'm not going to show that work. I'm just going to write the result of foiling. X squared minus x minus 6 plus 3x plus 6. Huh. Look at that. Negative 6 and positive 6. They cancel out. That leaves me with x squared plus 2x equals 0. Man, this x squared plus 2x feels so familiar. Almost like I've seen it somewhere in this question already. Well, whatever. It's a quadratic. We'll go ahead and solve it the same way we solve all quadratics. You factor it. Well, it's got a GCF of x. And now I can see my two solutions. They're x equals 0 and x equals negative 2. And our very last job, like I said, is to make sure your answers were allowed. At the very beginning, we can see you cannot plug in x equals 0. Makes one of the denominators 0. Oh, and we can't plug in x equals negative 2. Makes one of the denominators equal 0. So guess what? Both of these solutions are extraneous. There is no solution. How about that? So yeah, it happens. There's a lot of steps in a question like this. Is there anything I could do for you guys? Anything I can help you with? Yes, ma'am. Oh, a question from yesterday's review. Okay, but how about this? No? All right. Oh, okay. What happens if the denominators don't factor? Unfortunately, and I won't do that to you, but if the denominators did not factor, you'd be forced to find a least common denominator that's a product of two quadratics, and it's just ugly. It's possible, it's doable, but whew, it's mean, and I won't do it to you. I don't have a reason to make you work that hard. But yes, it would be bad times, I can tell you that.